Here we go with Module 1, Lesson 25. Looking at your notes, your learning target is that you can write a fraction and a decimal as a percent. You're going to do that as a whole quantity and write a percent of a whole quantity as a fraction or decimal. So we're still looking at that connection between fractions, decimals, and percents. And here we go. Make sure you have your pencil ready. A survey was taken that asked participants whether or not they were happy with their job. An overall score was given. 300 of the participants were unhappy, while 700 of the participants were happy with their job. Give a part to whole fraction for comparing happy participants to the whole. All right, so first part of this, we're going to look at the happy participants. Let me just go ahead and underline a couple of key things here. I know 300 were unhappy and 700 were happy. So knowing that, if I look at the happy, I'm going to say 700. That's a 7. Is the first part, but it wants the whole. Is 300 the whole? No, those are the unhappy. So we have to add those two together to get the whole. 300 plus 700 is 1,000. So this is 700 out of 1,000. As a percent, we're going to do the same thing, thinking about how we took the number and put it over 100. But I want to show you a trick. You can take your fraction of 700 out of 1,000. You're basically going to divide by 10, which erases those zeros. And now I can see that 70 over 100, like we talked about with lesson 24. So that percentage is 70% that are happy. Now, taking a look at the unhappy, I know that there are 300 unhappy, and the whole does not change. It's still out of 1,000 people. Translating that to a percent, we're going to do the same thing. Divide both by 10, which gets rid of that 0. Now I have my part over 100, which is 30%. This part, you can cross that off. We are not going to do the create a model to justify the answer because we basically just showed what we needed to show. Okay, moving on to your next section. Whoops. There we go. So Renita claims that a score of 80% means that she answered 4/5 of the problems correctly. She drew the following picture to support her claim. So first of all, I just want to know if she's right or wrong and why or why not. So the first thing I need to do is look at this 80%. 80% means that 80 out of 100 of these need to be shaded. Well, let's figure out if we even have 100 here. So here's 1, 2, 3, 4, 5. So I know that I have 5 rows. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 columns. So yes, 5 times 20 is 100. So I know I'm working with 100. And I can count these up and think 20, 40, 60, 80. So yes, I know that that means that 80% is shaded. Now I'm trying to decide if that is the same thing as saying 4/5. If I look at how this was broken up, I have 5 full rows, correct? And 4 of them are shaded. So that means 4/5 are shaded, that she got them correct. So yes, she is correct that 80% is the same thing as 4/5. And you can write a sentence that says something along the lines of, we proved it by counting the number of squares. and comparing that to the fractional part. You write your sentence however you can justify it. All right. Let's take a look at the next section. Oh, wait, at the very bottom of your paper, it says, how could you change Renita's picture to make it easier? Cross that off. Don't worry about it. We're not going to fill in that part. Then you can switch on to exercise 2. We're going to sort of take a look at this double number line to show the connection between the percentage and the fractional part. So on your paper, you have 1, 2, 3, 4, 5 sections, and below are the percentage equivalents. So obviously 0 is 0. If I'm breaking up that 100% into 5 sections, I know that I have to divide by 5, which is in 20%. So 20, 40, 60, 80, and 100. So looking here, 80 is what fraction of the whole quantity, or 80%. Here is 80%. It aligns with our 4. Our whole is 5, so it is 4/5 of the whole. And if you want to really look at that connection, when we've talked about equivalent ratios and equivalent fractions, go times 2 on both. That equals 8 out of 10, which really is 80 out of 100, which you know is 80%. So I wanted to show you that equivalent as well. Down here, 1/5 is what percent of the whole quantity. So this is the 1/5 that they're talking about here. This is that leftover that's not part of it. Well, I know from 80 to 100%, that's 20% left. So it is 20%. And I could do the same thing here. I can write my 1/5, multiply times 2. Then I get my 2/10. That is also equivalent to 20 over 100 if I multiplied by 10, and boom, there's your 20%. All right. Make sure you have all of that. Pause if you need to. Okay, now let's take a look at 50%. Well, 50% is not indicated on here. However, I can use the information that I have to identify where it is. So looking, here's 40, here's 60. I know 50% would be right in the middle of it. So that's my indicator of 50%. And I need to know the fraction of the whole. Well, it's in between 2 and 3, which means 2.5. So it is 2.5 out of 5, out of the whole 5. Oh, there go the dogs. They just needed to be part of the lesson as well, All right, 1%. Let's take a look at 1%. It's way down here, really, 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 really close to the 0. So 1%, 1 is what percent of the whole quantity? Well, if I have 5 as my whole, it's going to be super, 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 super small. But if I take a look, I'm looking for just plain old percent, and percent is out of 100. So 1 is just going to be 1% of that whole. Okay, so you are going to complete exercise 5 on your own. So we're skipping 4. You're going to fill in this chart, converting what you see, the fractions or decimals or percents, back into fractions, decimals, and percents. You're going to have to really think about those rules and those patterns that we used with the other chart. This right here is not a fraction over 100, so think about what I did earlier in the video to try to get that to 100. This guy right here is going to be the tricky one. I'm going to have you brainstorm on how to get that to a decimal and a percent. And if you put on your paper that it is 1.8 as a decimal, we're going to be having some words because that is not how you do it. You don't just take the numbers and make them into a decimal or a percent when it's not over 100 like that. So I want you to do some brainstorming and see if you can figure out a way to get that fraction to that decimal and percent equivalent.